Your AI agent update went bad. Maybe it started making the wrong decision. Maybe a prompt change broke the workflow. Maybe a tool permission was too broad. Maybe retrieval started pulling stale context. The question not just how do we fix the prompt. The better question is how do we roll this system back safely? A lot of teams treat AI agent rollback like an emergency scramble. Someone notices a bad output. Someone jumps into the prompt. Someone changes a setting. Someone disables a tool. Then everyone hopes the next run behaves better. That is not rollback. That is improvising in production. A real rollback process does three things. First, it stops the agent from causing more damage. Second, it preserves enough evidence to understand what happened. Third, it restores a known good operating state before new changes go live again. This matters because an AI agent is not just one model response. It is prompts, policies, tools, permissions, retrieval, memory, schedules, workflows, and human approval paths. If you only roll back one piece, the system may still be unsafe. So in this video, we are going to walk through a practical AI agent rollback plan. Rollback means returning the agent to a previously trusted state. That might mean restoring the last prompt version. It might mean reverting a policy file. It might mean disabling a new tool. It might mean restoring a previous model configuration. It might mean switching retrieval back to a known good index. It might mean putting the agent into assisted mode instead of full autonomy. The key is that rollback should be specific. Not say the agent is broken, say exactly which layer is being rolled back, prompt, model, tool permissions, policy, retrieval, memory, schedule, workflow routing, approval rules. If you cannot name the layer, you probably cannot roll it back cleanly. The first step is to pause risky actions. Not every agent needs to be shut off completely. If the agent is only reading data and summarizing it, you may keep it running in read-only mode. But if it can create tickets, update statuses, send messages, change priorities, approve exceptions, or trigger workflows, those actions need a pause path. This is where your kill switch connects to rollback. The kill switch buys time. Rollback restores trust. A good rollback plan defines a safe operating modes ahead of time. Live mode, assisted mode, read-only mode, paused mode. During a bad update, move the agent into the safest mode that still preserves useful context. The goal is not drama. The goal is containment. Before you overwrite anything, preserve the failed run, save the run ID, save the input, save the retrieved context, save the tool calls, save the tool responses, save the prompt version, save the policy version, save the model configuration, save the human approval trail, save the final output. If you wipe the evidence while trying to fix the problem, you make the next incident harder to investigate. A rollback should not erase the failure, it should freeze it. That frozen record becomes the test case you use before the agent goes live again. Now identify the rollback scope. Ask what changed before the bad behavior started. Was there a new prompt, a new tool, a new permission, a new policy rule, a new retrieval source, a new model version, a new schedule, a new workflow integration? You are looking for the smallest safe rollback. If only a new prompt caused the issue, restore the previous prompt. If the issue came from tool permissions, remove or reduce the tool access. If the issue came from stale retrieval, roll back the index or disable that source. If the issue came from an ambiguous policy, move the agent into assisted mode until the policy is clarified. The mistake is treating every failure like a full system failure. Sometimes you need a full stop, but often you need a targeted rollback. The next step is restoring a known good version. Known good does not mean perfect. It means previously tested, previously approved, and previously stable enough for the workflow. For AI agents, a known good version should include more than code. It should include the prompt version, the policy version, the tool, the workflow. For AI agents, a known good version should include more than code. It should include the prompt version, the policy version, the tool manifest, the permission set, the retrieval configuration, the model configuration, the approval rules, the environment settings. This is why version control matters. If your agent is configured by random dashboard clicks, rollback becomes guesswork. If your agent is configured by files, manifests, and release notes, rollback becomes operational. You can restore a specific state instead of trying to remember what changed. After restoring the known good version, do not immediately return to full autonomy. Switch to a safe operating mode. For example, the agent can generate recommendations but not take action. It can draft tickets but not submit them. It can classify findings but not change priority. It can prepare a customer update but not send it. It can summarize evidence but require approval before routing. This mode lets you confirm the rollback worked without giving the agent full control right away. Think of it like bringing a service back online after an incident. You do not just flip everything back on and walk away. You monitor the restored state. Now run regression tests. Use the failed case from the incident. Use a few normal cases. Use edge cases that are close to the failure. If the agent downgraded a critical vulnerability incorrectly, test that exact vulnerability again, then test similar vulnerabilities. Then test lower risk vulnerabilities to make sure the agent is not overcorrecting. Regression tests should check the whole decision path, input, context, retrieved evidence, policy interpretation, tool calls, approval requirement, final recommendation. If the rollback passes one happy path test, that is not enough. You want evidence that the failure is contained and the known good version behaves as expected. Once the system is stable, reintroduce changes gradually. Do not bundle 5 fixes together and call it resolved. Change one layer at a time. Update the prompt, test it, update the policy, test it, update the retrieval source, test it, re-enable a tool, test it. This is slower than pushing everything at once, but it gives you a clear signal. If the bad behavior returns, you know which change caused it. This is how AI agent teams become operationally mature. They treat prompts, tools, policies, and context like real production components. Here is a cybersecurity example. Vulnerability triage agent normally reviews scanner findings, checks asset criticality, checks known exploited status, and recommends priority. New prompt update tells the agent to reduce alert fatigue. After deployment, the agent starts downgrading internet-facing vulnerabilities because they do not have confirmed exploit activity yet. That is dangerous. The rollback process should be clear. First, pause automatic priority changes. Second, preserve the failed run and evidence. Third, identify the scope the prompt changed, but the tool permissions and data sources are still valid. Fourth, restore the previous prompt version. Fifth, run the agent in assisted mode. Sixth, retest the failed vulnerability and similar cases. Seventh, rewrite the prompt change more carefully and reintroduce it only after tests pass. That is a rollback plan, not panic, not random editing. A controlled return to a trusted state. Here's the checklist. Pause risky actions, preserve the failed run, identify the rollback scope, restore the known good version, switch to safe operating mode, run regression tests, reintroduce changes gradually, and document what changed. If your AI agent can affect real work, rollback cannot be an afterthought. You need it before launch, because the question is not whether an agent update will eventually behave differently than expected. It will. The question is whether you can restore control when it happens. If you want more practical AI agents for cybersecurity and automation, subscribe.